Okay, better, I guess?
Yep.
Good. So yeah, thanks everybody. And yeah, I know I'm basically one of the last things holding you up from the well-deserved post-conference beer. So but I'll promise to try and make this worthwhile. So what I'm going to talk about is flow-based programming. Before we get there, how many of you have actually heard about it before? A couple of hands. Good. Well, after this, there will be a bit more hands. So, quick introduction. Yeah, I'm from Finland, living in Berlin for the last 5 years. I've been doing webby stuff for a bit over 20 years now. Mostly content management, but lately also these new kinds of programming tools that I'm going to talk about. So, to start with, let's talk a little bit about control flow. This is actually something that was briefly discussed in the previous presentation as well. So, how many of you are, let's say, PHP developers? Yeah, a good half of the room, I would say. Okay, so this is the pattern you are kind of familiar with. In this case, in JavaScript, but the flow of the program is such that when you make some sort of function call. Let's say you're reading from a database, or saving a file, or requesting some external web service. The execution of your program basically stops until the response comes back. And the problem here is that, occasionally, let's say you're doing a web server, occasionally there might actually be more than one person visiting your website at the same time. And the way you usually get around it is by running multiple instances of the system, like multiple PHP instances, multiple Apache children, etc. So that's one way to do things, but it adds complexity to the deployment model. Now, how many of you have done any Node.js? Roughly the same number. I'm not sure if they're the same hands too. Okay, so at least Node.js people will be familiar with the continuation passing style, where you call a function. Again, you're about to do something that talks to network, does some I/O. And what you do is you give that function a callback function, another function, like, okay, go and do this thing and call me when you're ready. And what this allows the software to do is to keep running other stuff and then returning here when that particular I/O is done. In Node.js, for instance, there is a single thread that runs all your application logic, but then for any I/O, whether it's network or file system or whatever, Node.js spawns other thread to do that operation, and when it comes back, then it calls the function back in your main thread. And this way, with a single main thread of your application, you can actually serve thousands of requests at the same time, no problem. But it comes with a cost. I can say that my first Node.js applications looked like this. I'd imagine it was the same for many of you. It just becomes very difficult to follow the convoluted path of different callbacks and stuff. Okay, things like promises help a little bit there, but in reality, what would be nice would be to have some sort of a map. Where you can actually see, like, okay, this thing talks to that thing, and you can actually follow how to get to that damn conference. Yeah. So, wouldn't it be nice to actually see your software this way? Okay, this is basically where I come to the picture. So, 6 years ago, pretty much exactly, kind of transitioning from PHP to the JavaScript world. And that caused a lot of frustration, lots of, I had to rethink a lot of things. And happily I happened to be doing some consulting in the US, and I had to do some long drives on the West Coast, like between San Francisco and Portland, and it gave me a lot of time to think. And read some research papers in hotel rooms. And one of the things I ran into was the concept of flow-based programming invented by this gentleman in the picture here, Paul Merson. This is not new by any means. Like, okay, the book you're seeing there was published in 2011. He's retired now, so he's trying to write. But actually, the concept of flow-based programming was already invented by him in late 60s, early 70s at IBM, where they were actually using this to build some banking systems. So what we're talking about here is like really cutting-edge technology. To understand flow-based programming, you have to understand how software development worked back in the 60s. So what you had was these unit record machines, these machines that would basically process punch cards. Punch cards were the data, and punch cards could also be some configuration for the algorithm, but the actual, the algorithm was actually a flowchart telling, when there are punch cards in this tray, you have to take them and carry them to this machine that will do the next part of the algorithm. And so you had these machines on the left. This is collation machine here, and then you had people manually designing these flowcharts of where to take a piece of data. If this algorithm spits out the card here, put it there. If it goes there, put it there, etc. And then you had humans actually doing the networking. And yeah, flow-based programming was basically to take these concepts, basically thinking of software, these black boxes, these machines that do something, and then thinking of the bigger control flow as a flow chart of where to take your data packets next. JPM, Paul Morrison wasn't the only one thinking about programming in this way. Very similar time scale. Alan Kay came up with the idea of object-oriented programming, where his idea was that pieces of software would be kind of cells that communicate by sending messages to each other. But I mean, as we know, what came out of that was Java, so. Yeah, another area where we may have run into these concepts is the Unix system. I'm not going to read that out, but basically the idea there is, again, these black boxes, these individual programs that do one thing, and then being able to connect those to each other. And so, if you've ever used the pipe character on the command line, we saw that from the last presentation, for instance, you have actually done flow-based programming. So how many of you have done this? How many of you have actually had to figure out how to kill Firefox like this? So this is flow-based programming, but even though you can use splits and merges, generally people only do this in one dimension. We just string things along. And what we're talking about here is actually flow-based programming in 2D. So this is actually a running piece of NoFlo software here. And you can see there's connections between different processes, and then you can do some routing here where you can, here, errors would go there, success would go there, etc. And yeah, with NoFlo you can do nifty things like you can actually see the data packets traveling through in real time. But now, because I don't know if we're going to have time for questions, the timekeeping here seems pretty strict, I'm going to ask one for you. So hasn't this been tried before, right? This kind of visual programming or such things, there have been many approaches at this. But actually, I would say it really hasn't, because the things that have been done in visual programming space have mostly been very domain specific. You have things like LabVIEW for engineering simulation space. You have the blueprint stuff for game development. A lot of motion graphics industry uses tools that look very much like this. But nobody's really cracked or even attempted to crack the general purpose programming in this way. And that's what we set out to do with NoFlo. And the reason NoFlo is for JavaScript, it wasn't only because, yeah, I mean, Node.js is cool and all that. It's because JavaScript is what I consider a universal runtime. Like, if something can run software, it can generally run JavaScript. Like, even the most tightly locked down devices, like an iPhone, you know, I can bypass the Apple App Store rules by giving somebody a web page that runs by JavaScript, right? And so, yeah, this can run anywhere. You can run it on a server, you can run it on all the clients. So that's nice. A little bit about the API. So NoFlo provides a bunch of stuff. There's things for defining the graphs, network lifecycle, all that stuff. But the basic thing is, how do you build a component? How do you build one of those boxes? And there's two ways. One way is you can write link code. And this here is very kind of simple components. This will probably help to understand it a little bit more. So there's a few parts that you have to do. So first of all, you just provide a component interface. You just say, okay, this is an NoFlo component. Then the important part is defining what ports your component has. So you can have multiple imports, you can have multiple outports, and it's completely up to you what they mean and what they do. But like in, out, and error are very common pattern that many components use. And then you want to provide data types so that UIs can give better guidance on what can be connected with what. And then the next part is actually the meat of the component. So here you provide the processing function. So this is a callback that gets called whenever that component receives data. So the components don't know anything about the outside world. They will know, okay, I'm a component, I'm running now, oh, we got data, great, let's do something about it. And in this case, you do your precondition, like, okay, do we have actually data in the import? You might have multiple ports, so you might want to check, like, do I have all the data I need to actually run something? And then we read the data, read a packet from the import. So this is basically, somebody gave us a punch card and I read it in. And then you do something, in this case, we read the file from the disk. And then we handle the error case, like let's say the file didn't exist. We just send the error to the error port. And if the thing was successful, we send it to the out port. And then we say, done, okay, we have processed, so this lets NoFlo, the network know that, okay, this component is now finished. But yeah, I mean, writing components is one thing, but like there are hundreds of them out there. Like I think there's more than 100 NPM modules, and all of them usually provide multiple components. So for typical NoFlo projects, like maybe you need to write one component to do something specific, but usually like all the stuff you need to do is already out there. Actually, like for instance, Redis that we just heard about, there's a very nice set of Redis components for NoFlo, so you can just do all the pubs up and get them set and all that stuff visually. And yeah, of course, this also works the other way around because, I mean, not everybody, like you might want to build a library that somebody who is not using NoFlo might want to consume. And for that, we have this API called asCallback, which basically takes some component and it gives you a JavaScript function that will internally run the NoFlo component or pull NoFlo graph and basically make that NoFlo graph behave like a normal Node.js or JavaScript function. So this is nice for kind of like being able to go both ways. Like when you write a component, it's easy to grab an existing JavaScript API as a NoFlo component, and this way it's easy to represent the NoFlo graph or NoFlo component again as a JavaScript function. Probably doesn't make sense to like do these inside each other, but it's nice to be able to like that non-NoFlo consumers also utilize the things we have. So how do you define flows? There's people who love their text editors, and for that, IBM again, in the, I think, early 80s, developed this wonderful DSL where you can define a graph. So basically these arrows are edges, so they're connections between something. So in this case, for instance, we are sending a literal data packet with value 80 to the port, input port of the server node. So that's basically, that particular thing here tells a NoFlo web server component to start sending to port 80. So that's enough, that's all that we need to build a web server. And then we send the application instance from that to a middleware, so we can do some stuff like that. And then here we mount the resource to an image, /image, and that's it. That's basically what we need to do to a REST API. But I mean, this is nice as like, yeah, sometimes writing text is nice, but really, like, what we want to do is this, right? This is exactly the same graph you just saw in the previous text slide. In this case, it's just represented visually. And yeah, I mean, it's nicer because you actually see, okay, well, you know, we have the web server here, we are sending the port 80 there. But for instance, right now we are not handling the potential error in this program because, yeah, there's nothing connected to the error point. What happens if somebody else has already bound to that port 80? The server can't start, this program will crash. And the other thing here is, like, we have this resource component, which is really cool when you're building APIs. Like if you're building a REST API, this one allows you to create a resource with a certain path, and then you have all the different standard REST methods basically mapped to output ports. So when somebody does a post to that resource, you get a packet sent to the create port with the payload. When somebody sends a delete to individual one, it goes there, etc. So with this, yeah, you can, like, building a REST API is super simple with this one. The values there are standard Node.js request response pairs, so you can easily get the values that the user sends. You can add additional middlewares like authentication, JSON schema validation, whatever there, and go with it. To have this UI, what we did was, I mean, it's quite a lot of work to build an IDE, right? So what we did was we did a Kickstarter in 2013 to fund the development. That was very successful. I don't know if any of you funded it, but if you did, thank you very much. It was, you did? Oh, thank you. Yeah, so yeah, it was, I think, the fifth largest software Kickstarter back in the day. And the result we published as an MIT licensed project. But for reasons that I'm going to explain in a short while, I mean, in the Kickstarter times we called it NoFlo development environment because that's what it was. It was an ID for building things with NoFlo. But there were certain reasons why we rebranded it as Flow recently. So, like, if you want to start playing with this stuff, like Flow.io is the address you're probably going to want to do. And yeah, this is how it looks like in action. So this is a NoFlo program targeting the browser. So actually, in this case, NoFlo is running in that iframe right there. And what this graph is a pretty complicated one, but what it does, it starts your webcam, and then there's a bunch of input elements there that you can use to choose between different filters. So you can do little effects on the live video feed. These are GL shaders, so it's really fast. And I mean, sometimes you, as I said, you need to write components. So right in the UI, you can do that too. So you just click new component, boom, you get the code editor. Here's a component for parsing Markdown to HTML. And yeah, this one's written in CoffeeScript. I know a lot of people hate CoffeeScript, but I don't like unnecessary punctuation, so I often write things in CoffeeScript. But with NoFlo, it doesn't matter. You can write your stuff in plain JavaScript, the modern fancy stuff, or you can use CoffeeScript or TypeScript or whatever you like. And here, because testing is also important. One thing you can see here is tests for this particular component, and this one's using a tool called FTP-spec, which is a data-driven testing tool. So you just write your test cases in YAML, and then Flowhub can actually execute them against your component. And what Flowhub can also do is synchronize your projects with GitHub. So Flowhub works completely offline. Everything's in your local index DB. We don't have any servers that touch people's code. But you can authenticate with it with the GitHub API, and that you can actually do commits, pushes and pulls right from the UI. So a couple of example projects you can do with this. IoT is cool, right? How many of you played the game Ingress? A few. Pokemon Go. Very few. I'm surprised. Okay, so this is an augmented reality game by Niantic Labs, which also made Pokemon Go later. And yeah, a lot of people in my local hackerspace in Berlin are very active Ingress players, so we thought we would build this table, the hackerspace bar, where you can see the portals around our hackerspace and which faction owns them, what their status is. And so we built it as a NoFlo program. Here we fetch the data, for instance, then we do certain cleanup on it, and then finally we send the sanitized data over some USB connection to the microcontrollers that actually run the light. And so this is a nice little example of something that's been running in production for a few years now. And it's really cool to play with physical animations, the visual programming tool. There were a couple talks on React today, and here's a little example of that. This is basically the flux pattern done purely in visual programming, so there's not using any libraries from the flux stuff, and it's not using any custom components. Here we're just using some standard NoFlo stuff. And as you can see, here we mount a React component to the iframe here. And then whenever user does something there, the events get sent through this wire back here, and they go to the appropriate store to store something to state, which gets sent back to the view, and that gets rendered. And again, you can see the data as it goes through. So here's a create event that created that task. There was a remove event that removed another task from the to-do list. And of course, if you want to go fancy, you can do something like Redux. This is actually a screenshot from the NoFlo graph that runs the IDE itself. These are basically the middlewares that we use as part of the data flow of the IDE itself. So there's a logger, there's handling for URL changes, so when users navigate to a different URL, there's things dealing with persistent user information, there's middleware for talking to a runtime. And yeah, the way all of this works is we have this thing called the FTP protocol. So this is the reason why we went with Flowhub instead of NoFlo UI. Because actually, when we were solving the problem of how to talk with both a NoFlo system running on Node.js and in browser, we had to implement some sort of wire protocol. And it turns out, once you have a wire protocol, other people can implement it too. And so there are a bunch of other flow-based systems. So if JavaScript is not your cup of tea, if you're more like a Python person or whatever, you can actually use one of the other runtimes with the same tools. And yeah, there's a couple of runtimes I would like to highlight here. So image flow, this is a pretty cool one. How many of you have used GIMP? Okay, GIMP is a little bit like an open source version. And underneath GIMP, actually, the image processing engine is called Gaggle. And Gaggle is actually a flow-based environment. So what image flow does is it just takes Gaggle and it exposes it as a runtime so that you can do visual programming against it. And this means you can use the same tool that we use for programming JavaScript applications. You can actually use the same tool for building in plugins. So if you want to do some complex set of operations on a bunch of images, you can just use this tool with live preview and tweak the plugin, publish it, load it in your desktop application, and then you have built a plugin already visually. And yeah, you can even write the NuGet operations in C using our code editor if you want. And one other cool thing about ImageFlow is that it also comes with a tool called ImageFlow Server, which allows you to mount these GitHub plugins as a web service, which means you can have an application server running which you can use to run any kind of image processing operations, not just rescaling and these things that all these CMSs can do nowadays, but you can actually run like complex operations on a bunch of images together and get them served over HTTP. So that's pretty neat. Then another one that's nice is MicroFlow. This is for programming microcontrollers. Supports a bunch of different ones. I mean, microcontroller programming is not super difficult, but it's still usually done in C, which, as in the previous talk we learned, can be tricky, and very few people, at least in this room, knew about it. So with this, you can do visual programming against the microcontroller, and this one came out from a real need. So the person who built it had a fridge that was broken. The thermostat on the fridge was broken, but it was still otherwise a good fridge, and he didn't want to throw it away. So he wanted to build his own thermostat for the fridge, and he ended up building this tool using our Visual IDE for reprogramming his fridge. And as an end result, we not only have this open source project, but in addition, he has now an internet-connected fridge built in 1970s in East Germany. So sometimes software can be difficult here. Yeah, and people have built a bunch of different runtimes. One that I use quite a lot these days is message flow, which allows you to orchestrate microservices over message queues using our visual tool. So that's also nice. And yeah, I mean, the other thing about the protocol is, our UI is just one way to interface with these runtimes. I know there's some people in the NoFlo community who would like to experiment building a 3D interface. Like we were now doing 2D flow-based programming, but 3D might be cool. You can maybe look behind a component and see the source code. I don't know. So yeah, who would like to see some live stuff? Cool. Let's see. So very, very basic things first. So how much time do we have? A few minutes? That's good. So here's a NoFlo program. You have the components laid out, and there's a connection between them, some data packets, and this being NoFlo, you can actually run it. Yeah, perfect. So this one here is just a little graph to render a clock in HTML. So there's a couple of ideally div elements there that are the hands, and it just changes the CSS rotation. But this being a visual programming environment, there's one thing that I should mention. I think, as developers, we're all used to this. You change the code, you compile, you restart the program over and over and over again to see the changes, right? And sometimes the compilation takes a long while, and then then you have to go on Reddit or Hacker News, and then you watch the whole day just to see that one change. So I think it's almost unethical to stop a running software process. Software are beings, and they should be allowed to run. So what we can do actually here is we can modify the software live. So I can make the time go faster, right? Do I go faster? Slower. Oh, slower? Okay. Let's go slower. Yeah. And yeah, the nice thing is is, yeah, I can click on a wire, I can see the values that go through here, and all that. And let's see. Here's one example with the webcam. Let's see if that works. So what this one does here is this is something useful if you're doing web applications. So let's take something a little more colorful, like this. Oh, there's the logo there. Yeah. So what it does here is it starts the webcam and loads it to a canvas element in Node.js, and then it extracts the dominant colors from the image. So this is something you could easily do if you were building a UI, for instance. You could use these same components to make the UI kind of react to the content colors. This is something that they do a lot, for instance, in material design. But I just wanted to show that it can work at least in semi-real time as well. And yeah, then a little bit. Yep. Okay. So let's show you how to modify something. So here we have a little graph that just, in this case, generates random pattern of colored blocks every time you click the button. That's nice, but maybe you'll want to actually make it behave differently. So we take the button and we disconnect it from that guy. And we connect it to this one, which is fun. This is strict sequence is a component that accepts multiple connections into this out port, and then when it gets the packet, it always sends the next one in the list. So what we can do with this is we can make an interval, and basically we can make the button either start or stop the interval. So this makes the little button, so you click it, the interval starts running, and you click it again, and the interval stops. And then we need one more component. This guy, that's mostly because of the certain behavior of this graph, that we need this one, so we can do this point. And now, if I didn't mess up, we should be able to start. This is an animation instead of a single click, and when we click it again, it stops. And you can see these mouse events being sent. So that here goes, loads there. So now if I click it, we can see one event going to the start port. Now when I click it again, it goes to the stop port, and the animation stops. So that's just a quick demo of how to modify things live, and that works with both Node.js and the browser. So that's a nice feature. Like you can actually do similar things here. This is actually connected to Node.js. So that's I think it. I do believe we have some time for questions.
So we have around 10 minutes for questions.
Thank you for the nice talk. I want to ask you, how hard it is to maintain structure of this visual, let's say, representation of code on something very complex?
Yeah, so the question was about how to structure complex things. One thing that I forgot to mention, so good that you asked, is that these graphs, or these nodes can either be code or they can be another graph. So you can actually use decomposition. I do believe I have an example of that here. So the prepare data box here is actually a graph. And then there's actually graphs inside this, and then you finally get to code. So that's one way you can organize your software when you're doing more complex things. But then, of course, this will not prevent you from doing spaghetti code. It's just the only difference is that here the spaghetti code will actually look like spaghetti.
Hey. Okay. So first say wow. That's really impressive. How's the if I want to integrate NoFlo in an app which already exists, how difficult is to do this? Like, isn't it even possible?
So the JavaScript application,
Yeah.
I assume. Client-side Node.js, which one?
Single page app.
Single page app. So are you using like Webpack, for instance?
Yeah.
Okay, then it will just work.
Okay.
I think I had an example here, like to basically wrap a NoFlo graph. You can just always use. There's a couple of other APIs to do this, but this is an easy way to wrap a NoFlo graph into like existing JavaScript code base. No, it's the graph is defined by the path there that you give to the Astrola. So when you do the rewire loads NoFlo, and then NoFlo loads its component library and so on. So that will mostly just work. And that's the way we built our own stuff too. So. Okay, anything else?
I'm relatively new in programming, so maybe my question is a bit naive, but they used to teach us that actually there's nothing random in computers. So I was wondering these mosaics of different colors and the animations, how they're actually generated, how random they really are.
Yeah, so I mean, this one is just using the normal map random function from JavaScript. That's not super random. Or more random you need other sources, but the good thing is like we don't have anything blocking you from using those if you really need it. But this is enough usually, like, for flipping the coin.
Okay, you go first.
By the way, while we're waiting for that to travel, we have a few stickers here from NoFlo. Somebody still wants to decorate their laptop.
I really like the whole idea, but I have a question. Performance-wise, compared, for example, to Grunt, which is a similar system, it's just not graphical, how efficient is it? Like, does it perform very quickly compared to other task systems, or is it slower? And running it in the graphical interface, I presume also makes it slower.
Yeah, so if you use NoFlo in a mode where you actually are connecting the GUI to the running system, then of course it becomes a little bit slower because it not only needs to do the thing it's doing, it also needs to tell the GUI about what it's doing. So there's a lot of serialization of stuff and sending it over to live. So that adds overhead. So I wouldn't recommend using the live mode with the production system. This is more about when you're building it or when you're debugging or whatever. As for otherwise the performance, I mean these edges, these wires that you see connecting the components, they're using the standard event emitters. So it's just basically an additional function call per edge. So there's a little bit of overhead, but like you won't really see it on that level.
Okay, so last question from me. How many components are there?
Well, this being an open source project, I have to say I don't know. I know, like, people who have actually upstreamed their components, the NoFlo org, have contributed 100 modules, and if we say on average a module has 10 components, then that gives you an answer of like let's say the standard library of NoFlo. But then there's like people build their own custom stuff, and if they don't tag it with the NoFlo keyword on NPM or if they don't publish it on NPM, we don't know.
Okay, thank you very much.